let's start talking about experiments. So experiments' main difference from a observational study is that in an experiment, the researcher is the one controlling for the variable that they believe influences things. So as we talked about in the last video, smoking's link to lung cancer was actually done just observationally. We just passively observed whether people smoked and whether they developed lung cancer later in life. That is not an experiment. In an experiment, what would happen is some people would be randomly selected to smoke and others would be randomly selected to not smoke. And then we'd see at the end of the study, or at the end of the experiment here, what kind of outcomes they had in terms of lung cancer, right? So, in other words, we researchers would be the ones deciding whether they are exposed to this risk factor or not. Okay, another popular one that we've seen both forms of this would be vitamins, right? So some have been just observational studies saying, oh, well, people that had high levels of vitamin D through vitamin supplements had better outcomes with COVID or something like that. That was a passive observational study. And then there's been follow-up experiments where they randomly assign some people to be taking vitamin D or whatever vitamin it is in higher quantities from supplements, and other people do not, right? So these groups that we tend to be separating things in with experiments, statistical experiments, are tend to be either they get a treatment or risk factor, or they do not get either the treatment or risk factor. Okay, so that's the idea here, is that the researchers are the ones directly intervening and deciding what treatment these individuals are being exposed to as they go through this experiment. Okay, so a well-designed experiment should have a control group, okay? And that's what I was essentially talking about there, right? If I just, like if every patient I had come to me, right, as a research doctor, if I gave them all the same drug, I wouldn't be able to tell how much better that drug is than doing nothing, right? Like, say everyone, like we have a flu epidemic, it just goes crazy, and we have a flu outbreak in a school district or something, and just suddenly everyone has the flu. Well, if we gave everyone flu medication and everyone didn't have the flu like 2 or 3 days later, well, did they just get better, or was it the drug, or what? Right? Well, without a control group, I can't answer that question. And so that's why some individuals need to not get the treatment. And those are the people in the control group, so that we can actually compare the outcome of the treatment or risk factor, right? Sometimes it's not a good thing, right? But some people get that, and some people don't get anything, so that you can actually compare the effects of the treatment to if they had gotten no treatment. So a good experiment should, at the minimum, have a control group. And when we're working on living things, we tend to really want a placebo specifically. So the individuals in the control group tend to get a placebo. And I want to give a couple of different examples here, just so you get this idea that not all placebos are like sugar pills that we see in TV shows. So I worked on an experiment that was looking at spraying leaves with fertilizer for corn crops. And it turns out that the act of spraying the leaves, right, just to be clear, obviously you put fertilizer in the soil, right? That's where they get the nutrients from, where they were trying to add on extra fertilizer and make it grow even better by spraying it on the leaves. And so the idea here is there's both positive and negative outcomes. One, it kind of cools the plants off in the heat of the sun, which is beneficial, right? But that has nothing to do with the fertilizer. And spraying things with water tends to add the possibility of molding or mildew or rot or whatever. And so there's some negative things to it also. And so instead of just spraying some plants with the fertilizer and not spraying others, what we did as a placebo was just spray some with just plain water and spray others with that fertilized water. And that way we could actually have a more apples to apples kind of comparison between the two. Okay, so that would be one actual placebo that has nothing to do with, right, any psychological effect at all. It's purely just a non-treatment that's intended to remove any like effects that aren't relevant to our study. Another one would be, I saw an experiment where they were looking to see the effects of hypnosis on pain treatment, on like people experiencing severe pain. And so what they did there was they actually had like trained psychologists that know about hypnosis or whatever, that do hypnotherapy, and had some patients go to them. And they had others go to an actor that literally did the, watch swinging back and forth like we've seen on TV, kind of nonsense, and just didn't know what they were doing and just kind of made up some stuff, right? And so there they were able to actually kind of eliminate those psychological effects of feeling like you got a treatment, because both groups felt like they just got a hypnotherapy treatment, and it was able to actually establish the differences between that, like, placebo, which again was not a physical pill that they took. It was just something that makes that eliminates the extra factors involved in the treatment that aren't relevant to our study, like just feeling like you got a treatment. And so this placebo effect, and the main reason we're doing that placebo, of course, is because for many, right, we mostly think about it in terms of medical stuff, but it absolutely was a placebo effect with those corn plants I was talking about earlier. Spraying them with just plain water actually did help in the peak of summertime to kind of cool them off a little bit, as long as it was done early in the day, not at night, because then they molded. But you know what I mean? Like there was a placebo effect there. And we tend to think of this psychologically, though, that this placebo effect is something where just in individuals feeling that they've just been given a treatment by a professional tends to increase outcomes for a myriad of reasons that I don't need to get into in this short video, but it tends to be a psychological effect, okay? And I will say, for any of you that are considering going into medicine, don't dismiss this placebo effect as like, oh, that means nothing works. You would be surprised at how much common medical practice nowadays is completely fine with placebo effect, because as long as you're not harming anybody or charging them an extra money or like not causing no harm whatsoever and improving outcomes, right? We tend to not really care if yoga and meditation and acupuncture and whatever those things are, if they don't really work, right, in a like physiological sense, but they have enough strong psychological effect, who really cares, right? Patients are getting better, okay? So I don't want to go too off topic with that, but this is a common thing going on in medical research now, is where to draw the line to where we're saying actually this particular kind of treatment has an incredibly strong placebo effect. Like it's clearly not causing any physiological change, right? There's no thing changing about their body, but it's causing enough of a psychological change that it's helping. Right, like meditation, like shouldn't, right? It makes no sense that it would be beneficial for recovering from cancer necessarily, right? But it does, because it has such a strong placebo effect, and kind of who cares sometimes, right? So don't just dismiss this as, oh, it was just a placebo effect. Sometimes the strength of that placebo effect can be something worth investigating. All right. Enough on that random tangent there. Last things we need to be really concerned with are these blind experiments and double-blind experiments. So in a blind experiment, the individual getting the treatment should not know whether they're getting the placebo or the treatment. I feel like this is obvious. This is like the minimum any person should ever be doing, is a blind experiment. A double-blind experiment goes one step further, that the administrator and the person that actually records the data also doesn't know who's getting the treatment and who's getting the placebo. And this was first noticed as nurses were going in the room and administering treatments, and administering placebos, if they knew which one was which, they were just kind of more like hopeful and like happy and like just in a different mood going in treating people with like, deadly diseases when they thought they were actually giving them a real treatment, and they would just be like, when they were going in and giving a placebo to somebody that was dying of some disease, right? It's got to be part of it. We've got to know who gets, or we've got to know if this treatment really works or if it's just a placebo effect. But we can't have that kind of situation where the person administering it is consciously or subconsciously influencing the results. So that's why the gold standard is what it's always called for experiments, is a double-blind controlled experiment, right? So this is where essentially we've got a treatment group and we've got some other group getting a placebo, and neither the individuals nor the actual like people administering those treatments have any idea which is which.